Hi to everybody. I will make this first presentation. Well, indeed, there will be 3 presentations of the live program during this symposium. Tomorrow about the works following these scientific follow-ups and also the communication implemented with all the tools. And we will also add the screening of the movie made for the live program. So quickly, background elements, things which were said during the introduction. So the Morvan stream constitutes a fragile ecosystem with an endangered species, the pearl mussel, and the streams of the Morvan are disturbed basins which are not taken into account in the development of the territory, with fragmentation of the ecological continuity, which is a limiting factor. Of course, we implement different actions in order to find these species again, and it will show us a good indicator of the quality of water. So quickly again, here you have got the implementation of the live programs. As we said before, we started with live in 2004, it finished in 2009, and we wanted to pursue the actions of this program and accentuate on the issue of ecological continuity. So this program will end in August 2017. For those who don't know where Bourgogne and Franche-Comté are, they are here on the map. So these 2 regions, which are only one now, so in gray on the map. In terms of budget, more than 3 million, and the contribution from the European Union. It's not easy on these figures, but it is 50% because we received more funds afterwards, with actions deployed with our partner, the Park of the Ballon des Bauges. What is a live program? It is not very used in France. Our European partners do better than us. It is a financial tool, first of all, for the life nature. We have got different aspects. It helps to finance actions for habitat and birds with this notion of target species. I talked about pearl mussels before. We also have other fish, the lamprey, for example. So it is an example for the management of other natural sites, and it is a very good way of communicating in terms of finances, co-funding from the European Union at 50%, and also a part given by our partners, water agencies, local authorities and state authorities. The parks themselves, with a small self-funding, so we can pay for studies, works, and so on. So the main part of the topic, the issue, here you have got a picture of the Cousin River with pearl mussels, one of the last ones in France. What you have to know about this species, it is that it needs a very good quality of water. So a few figures, you need to have less than 5 milliliters nitrates. For phosphorus it is the same, you need to have a good level. The cycle of reproduction with the truth, with larves, and then we have got young mussels, and they will go in the bed stream. So the third thing to preserve, it is the quality of the bed of the river, so that we have got oxygen for these young mussels. At the same time, on the Cousin, I will show you a map later on. We have got an historical heritage and a landscape heritage with a succession of rivers. The river was modified, so with different situations, but with an habitat which is not compatible for the existence of the pearl mussel and ruptures of connectivity for these mussels. So a small map so that you will understand better. So in pink, Natura 2000, different wares. In yellow, you have got the population of pearl mussels in two parts. In orange, you have got the limitation of the downstream for the quality of water with different impacts from one to another. So the different colors symbolizing the fact that you can cross the dams, and the size of the points, it is also about eddies size. So I've got a synthesis of the scientific results that we obtain with different studies from different research firms. We have got data from AFB, and we also carried out internal studies with someone working inside our company. So a succession of water bodies with the downstream with the next water body. So we have got 540 meters. We've got another work. For the Cousin, it is more every 1,400 meters. For the height, all the works are not in the same state, but with stones and feeding other rivers. So the height, more or less 2 meters, and if we have got a cumulative height, we have got 25 meters in total. So with these first elements, we have got cumulative effects which are necessary. We try to assess them afterwards. Then you have got a map at the top of the slide. It is a map made by Biotech with all the works and water bodies. A few elements about the crossing of obstacles. Some obstacles are considered that you cannot cross them. They are impossible. You can have economical use or landscape use with another element which is important as well. It is the division of surfaces, so free surfaces or lentic surfaces, and with low flow. For hydromorphology, a recent map from IGN, so you can see that the shapes of the bed are stable with a specific power of the river, but physical variations they go in the altitudinal sense with a progression of all the reservoirs, and at the entrance of them in the bed or downstream of the works. On the left picture, And on the right, you have got well, sediment transport. We have got a perturbation, which is momentaneous. So we have got sands and small stones, pebbles of 5 to 10 centimeters.
This is a graph to show you the habitat quality. It's difficult to explain in a few minutes, but basically this is the morphodynamic attraction level. On the bottom area, you have the quality indicator, very low in water retentions. At the top here, upstream quality level, and in intermediate, this is all a downstream dam where the river didn't completely recover. So we see strong fouling of the substrates. And another element, in the most recent works, we noticed after removing the works, we see great improvement in habitat quality. Here in Templiers, we almost restored to the reference quality level just 1 year after the actions. So if we look more specifically at the pearl mussel habitat, as we said, the population has low density level. And so we looked at capture, markings, recapture. So we noticed altitudinal movements in sediments, which we were able to follow. So this is one upstream work. We see the impact on retaining the population. This is the hydraulic conductivity graph. So this is a protocol where we use a tube and we look at the percolation speed of the water. So we see challenges on the left-hand side in the percolation and filtering capacity, and a restored percolation filtering capacity on the right-hand side. So we were able to correlate with oxygen levels. And looking at the oxygen level in each 10-15 centimeter layer, and look at how the oxygen rate reduces, we say it shouldn't reduce by more than 20% for pearl mussels to survive. And unfortunately, in the basins analyzed, we were beyond this level. In terms of water quality, it was fair. We didn't find trace metals or pesticides in the sediments, and we thought the physics and chemical parameters were satisfactory. In terms of temperature, however, the situation was worse. Looking at the different dams, the different barriers, and temperature level here, we see it increases. So there are different affluents and springs, however, feeding water into river. And there is an impact on the brown trout. These are the maximum temperatures and tolerance threshold for the brown trout, which is 18 to 20 degrees. And on the fishes and invertebrates, we see gaps, different profiles. This is the first station upstream, downstream, and the site with the higher number of works, obstacles. So we move here from B4 to B6, which has an influence on the fish's localization. So we also analyzed number of fishes in 2012 referenced the station called B6 and the non-disturbed reference, which is the level of the B4. So I'm trying to explain in simple terms, but basically all the different species we try to find in watersheds are not available. There is lesser number of species and a lesser number in the population of each species. If we look at invertebrates, the upstream station showed the right level of fishes of population for this type of stream. And we have intermediate areas, and on the left-hand side, after the dams, and we have a graph comparing the data before removal and after removal. 2 obstacles removed. So looking at the previous year and 2006, so we see the invertebrate population line. And the differences after removing more obstacles at the end of last year. So we're hoping to get the right ecological balance, better continuity by next year following these actions. So we see a strong correlation in the welcome station and the relation to the morphological status. We see the impact of the dams, of the obstacles on fishes populations and the cumulated effect. So it shows that the most efficient solution to restore this population is to get rid of the water retention effect upstream of the different works to restore hydromorphological conditions close to the upstream station. So now we'll try to restore the flow rate, avoid substrates fouling, substrate stagnation, and increase attractivity of this environment for the common trout. But tomorrow we think that we'll have issues with the hydraulic works future, because this is tricky to discuss with the infrastructure owners. We do have hopes and ambitions. We need to negotiate and discuss with infrastructure owners to try and get the right level of action for each of these works. Thank you so much for your attention. I listed here the different studies, the data I used. Thank you.